arithmetic or a geometric sequence, sorry. Is that an arithmetic or geometric? Geometric. Okay, geometric. And I know that it's geometric because of what? Okay, so there is a ratio, a common ratio, and the ratio is 3. What's the matter back there, Eli? No. Zach, okay, so if we could focus on this, I'd appreciate that. Thank you. Okay. So I know that the common ratio is 3, and just as we had in our arithmetic sequences, were we able to use what we called a recursive definition that we can make a prediction about a later term if we know what? The first term. Okay? The first term. If I know the first term, I can then figure out if I know my ratio. I should be able to make some predictions based on the others. So yesterday what we did was we looked at common ratio. I had my here. I had my terms. And how did we generate this rule? So the first term was a 1. My second term was the 1 times 3. We realized the ratio was 3. What is this 3 squared business?
N minus 1.
Okay, it is an n minus 1, but how do I know that that happens? Let's look at the number. And isn't that 3 squared represent the 9? Okay, and then isn't this 3 to the 3rd represent my 27? My 3 to the 4th is equal to my 81. But what happens with the exponent? So is the 3rd term, but I'm only going to use it to the 2nd power. It's going to be what? My 4th term, 1, 2, 3, 4. How many times at this point is this 3 being used to get to the 4th term? 3 times. Does it make sense that our rule is going to be n minus 1 because I'm using it 1 less time than the term?
So n is the term?
That's the place of the term.
Like what number term would you say?
That's right. So if I'm looking for, so we came up with a rule yesterday, and we said that the rule was the nth term, whatever it is. I don't know what the value is, but I have my first term times r being the what? The common ratio. And what is this n minus 1? It's the number of terms minus 1. So this n is really the same as this n. If I'm looking for what is the 10th term, I don't know what it is, but couldn't I then plug it in if I know the first term? I don't know what the 10th term is, but my first term was a 1. My ratio was what? 3. What is this n here? N is going to be my 10 minus 1, and that's going to be 9. Now, on your graphing calculators, I don't remember, did we talk about how to use exponents to higher powers?
No.
Okay, so take out your calculator, let me just show you that. Very simple. Okay, so clear your screen. Okay, so we were going to do, where's my pen? I believe we were doing a to the 10th is equal to 1 times 3 to the 9th. Yes? Okay, so let's enter in 3. So I'm just typing in 3. And I want you to see this key right here. It's right below the clear button, and it's called a caret. I don't know why, but it's called a caret. So it's going to be 3, and I'm using my caret key to the 9th power. So 3 to the 9th, enter, is 19,683. Okay, so that's how you use your calculator to plug in some exponent to a high power. Okay? All right. All right, so let's look at a couple of problems and see if we can solve for these. And these are classic word problems. Okay. And let's just take a look at a picture, because we love pictures, right? Do you know what this little guy is? How many of you have had strep throat? This is the stuff that's lurking in your throat. Streptococcus pneumoniae bacteria. Okay, that's the stuff. Okay, so let's look at this and think about how what happens with infections. All right, so public health records show that the number of infections can grow geometrically during the initial phase of an outbreak of strep throat. And if there were 3, 15, 45 people infected on the first 3 days of an outbreak of strep throat, and the geometric growth in the number of infections continues, okay, because you have to be careful. Do all things continue at the same, the geometric pattern may change along the way. So if they're saying if the number of infection continues, the geometric growth in the number of infection continues, how many people will be infected in the 7th day? Same approach that we used last time. What do we know?
The first term.
Do we know the first term? So I know a to the 1 is what? 5. Can I figure out a ratio?
3.
Ratio is 3. And what are they asking me to find?
7.
The 7. How do I write that? A sub 7 is equal to 5 times my ratio, which is 3, to the 6th. Okay. Order of operations, what are you going to do first? My exponents. So what is 3 to the 6th? 729 times 3, 6, 4, 5. What was the other formula?
It's pretty big.
Like the
Outbreak
ones that
of
are
strep throat.
I know, so what's the form? I'm asking you to give me the formula from memory.
Which one? The number of terms?
Yes, the sequence. How do I get the sequence? Isn't that the first term plus?
The last term divided by 2.
No, that's the sum.
Oh, and subtract 1.
The difference, yeah. So I mean, that's why I gave them to you as 2 separate quizzes, because I didn't want you to confuse them. Okay, so are we good with that one? All right. All right, so here's another variation. Let's try this one. The 11th term of a geometric sequence with a common ratio of 2 is 7,168. Give a formula for the nth term of the sequence. Okay, so what are you going to start with? Write down the formula. Exactly. Write down the formula. It's on page 252. Write down the formula, and the formula is what? A to the n is equal to a to the 1 times ratio to and subtract 1. Okay, well,
Plug in what you know.
plug in what you know. Thank you, Kayla. What do we know? We know where they say the 11th, the common ratio is 2,
It's the 11th term.
and the formula, the 11th term, so is that our n?
Yeah.
Okay, so what am I putting in here?
10.
10, okay, and what is 7,168? Okay, so that is 7168, right, is our 11th term, and what are we looking for? The first term?
It says give a formula for the nth term, so wouldn't that just be your original formula?
Well, let me see. I need to, if I would give a formula, but I need that
Oh,
information
you
there.
need the first one.
Right.
No, the last one you don't.
Okay, so I would need to solve that. Can I solve that? What is 2 to the 10th? 2 to the 10th is 1,024, 1,024?
Yes.
And so what do I have to do? Divide both sides. And what do I know the first term is? 7. Okay, so could I give a formula for the nth term? What would it be?
8 at the end.
Sub n.
7 times.
The ratio 2 to the n minus